Hello everyone. Today I'm excited to present my approach to providing a solution to the ongoing issue of integrating sustainability into the early stages of the architectural design process. The core of this research revolves around a prototype machine learning tool called the Early Stage Carbon Observer, abbreviated to ECO. To give you an idea of the stakes involved, buildings account for approximately 37% of global carbon emissions. Small adjustments in the design phase, such as changing the primary materials or altering the building shape, can potentially reduce total greenhouse gas emissions by up to 40%. Machine learning has been identified as a powerful tool to advance this goal, offering both predictive and optimization capabilities in the design process, with current predictive implementations using ML to provide predictions in the absence of sort of quantified detailed data. The main goal of ECO is to serve as an intelligent model that can translate early-stage architectural design descriptions into their associated total carbon footprints. For the purposes of this study, it has been connected to a web application front-end to provide simpler access for user testing. I'll explain the capabilities of ECO through a visual demonstration. To put it plainly, ECO is a lexical tool that takes a description and generates its associated total carbon value. For example, given the input, a museum with glass panes and steel supports, ECO might produce a carbon output of 1,444.47 kg CO2e per meter squared. You can then see these details. Here, it's decided that this building has a steel structure with steel piles, steel columns, steel beams, steel secondary beams. It's also picked a curtain wall facade, amongst other found features. The tool operates through a sophisticated pipeline that turns the initial descriptions into actionable data or structured data and runs them through a final histogram gradient boosting model. The model was chosen through a selection process involving a number of different models, automatically picking the most effective. The implementation process begins with the input of textual data. This will typically be unstructured and will contain information about materials, dimensions, and other architectural features. ECO then pre-processes this text, breaking it down into manageable units through a process called tokenization. Further pre-processing is done, such as stop word removal, lemmatization, and POS tagging, to remove unnecessary words and normalize the remaining text for further processing, ensuring consistency. The next step is feature extraction, where ECO identifies key elements within the text. This begins with categorical feature extraction. For explicit features, ECO essentially searches for direct mentions of materials, dimensions, and other relevant features within the text. For example, if a text mentions concrete pile foundations, ECO will capture concrete as a material and pile foundations as the feature. For more subtle or implicit features, such as, indirectly mentioned elements or simply spelling errors, ECO takes a more nuanced approach, using natural language processing techniques like named entity recognition to infer these. Logical rules and conflict resolution are then applied, with the structured data then fed into the HGB regression model, which is then returned to the machine client. Throughout testing, the tool showed promising results, but with further areas of improvement. ECO's ability to extract relevant features from text was tested by inputting various building descriptions. The tool generally performed well in identifying primary structures such as steel and timber, but it struggled with matching their internal counterparts, particularly when these features were not explicitly mentioned. In terms of accuracy, the tool consistently overestimated the carbon values, which I believe to stem from ECO's reliance on high-level description, lacking detailed information. Despite this, ECO was able to correctly identify the hierarchy of carbon intensity in designs, showing a trend that correlates moderately with the real data. Finally, ECO's ability to handle linguistic variability was tested by rephrasing descriptions of the same building designs. ECO was able to maintain consistency across different design descriptions. However, some situations exhibited fairly significant fluctuations. Users who tested the tool found it to be useful in raising their awareness of what affects the overall carbon emissions, though some noted a few developmental areas such as greater transparency in the tool's calculations or additional features such as integration with CAD software. Overall, ECO demonstrated a strong ability to extract and predict embodied carbon. Areas for improvement were identified, particularly in handling complex features such as numerical formats, or in improving its overall accuracy. Thank you.